In this video, we're going to use what we know about parallel circuits, voltage, current, and resistances in parallel to solve an entire parallel circuit. Here we have a parallel circuit. We have a source of EMF in parallel with R1, R2, and R3. And here's our EMF. This is R1, 5 ohms. R2 is 15 ohms. And R3 is also 5 ohms. So there are actually a lot of different ways we can solve this, and we can solve it in a bunch of different orders. Our goal is going to be to find V, I, and R for each resistor and for the whole circuit. So to do that, we're going to find R equivalent. That's the total resistance of the circuit. We're going to use Ohm's law to find the total current. And then we can use V equals IR for each individual branch to find the current through each branch using what we know about parallel circuits. Before we do that, I'm going to fill in our givens. We're given the EMF is 24 volts, so that is our total voltage, 24 volts. R1 is 5 ohms. R2 is 15 ohms. And R3 is 5 ohms as well. So let's just go through step one. We're going to find the total equivalent resistance. I'm going to zoom in a little here. So we know that we have R1, R2, and R3 in parallel, so our equation for equivalent resistance is R equivalent to the minus 1 is equal to R1 to the minus 1 plus R2 to the minus 1 plus R3 to the minus 1. And we can plug in some numbers there. We're going to get 5 ohms to the minus 1 plus 15 ohms to the minus 1 plus 5 ohms to the minus 1. When we add all of those up, we get 1 over R equivalent, or R equivalent to the minus 1, is equal to, that's equal to 0.466 repeating, and it's going to be per ohm. So in order to get the total equivalent resistance, we actually need to take the reciprocal of both sides. We take the reciprocal of both sides, we get R equivalent is equal to 2.143 ohms. And I'm doing a lot of sig figs here, way too many, just so that rounding errors don't hurt me later. I'm going to fill that in under our total resistance over here in red. R equivalent is 2.14 ohms. Next up, we are going to use Ohm's law to find the total current. That is going to be the current coming from the battery. So I'm going to label that here, I total. And we would also have I1, I2, I3. So let's zoom in again and just use Ohm's law to find our total current. We're going to use V total is equal to I total, R total, or R equivalent. And that implies that I total is equal to V total over R total. So that's going to give us, we have a voltage of 24 volts divided by 2.143 ohms. That gives us a current of 11.2 amperes. That's a whole lot of current. Let's fill that in over here. 11.2 amperes. Well, we have the total. Now we need to solve for the individual resistors, the individual branches here. And we're going to use what we know about parallel circuits to do this. First of all, we know that the potential difference across this battery is 24 volts. But we also know that voltage is constant in parallel. So that means if we start on this bottom conductor and we end up on this negative conductor, this top conductor, the potential difference is always going to be the same. It's got to be 24 volts if we start in the same place and end in the same place. So that means the potential difference across each one of these resistors has to be also 24 volts. So I'm going to fill that in over here. It's going to be 24 volts, 24 volts, and 24 volts. Well, we're almost done. Now all we have to do is use Ohm's law for each individual resistor to figure out the current running through each branch. So let's check that out. I'm going to use green for this one. So let's look at, if we're looking at R1, then we know V1 equals I1 R1. So that means I1 is equal to V1 over R1. And V1 is 24 volts. 24 volts divided by a resistance of 5 ohms gives us 4.8 amperes. I1 is 4.8 amperes. I'm going to do the same thing for R2. V2 equals I2 R2, which implies I2 equals V2 over R2. 24 volts over 5 ohms gives us, the resistance of R2 is not 5 ohms, it is 15 ohms. 24 over 15 ohms gives us 1.6 amperes. And R3, well, R3 is the same as R1, so when we do I equals V over R, then we're going to get the same answer as R1 since everything's the same, 4.8 amperes. So let's fill those in. 4.8 amperes and 1.6 amperes. And that's it. We have solved for everything. Now, one thing I want to do is I want to check my answer. And to do that, I'm going to look at the currents that we solved for. We know that the total current is 11.2 amperes. And as that current travels throughout the circuit, it's going to split among the 3 paths. So the 3 paths should add up to 11.2 amps of current. So let's check that I1 plus I2 plus I3 is equal to 11.2 amperes. So we're going to check for reasonableness. I1 plus I2 plus I3 equals 4.8 amps plus 1.6 amps plus 4.8 amps. That gives exactly 11.2 amperes. So that's great. We did it. Everything looks good. Our circuit is 100% solved.